Okay, today we're working through the quadratic formula. It is yet another way to solve a quadratic function or a quadratic equation. So we're solving quadratic equations using the quadratic formula, and we'll also classify roots using the discriminant. At the end, we're going to have a chart that sort of talks about the many different ways we've learned to solve quadratic equations, quadratic functions, and how you can choose which one to use. The only new vocabulary word today is the discriminant, which is sort of difficult to spell. All right, you have learned several methods for solving quadratic equations. We graph, we make tables, we factor, use square roots, complete the square, and now we're going to learn the quadratic formula, which allows you to solve a quadratic equation in standard form. Get that? Standard form. It must be in standard form. By completing the square in the standard form quadratic equation, you can determine the quadratic formula. So the next slide is how the quadratic formula was developed. I would love it if you would work through every detail and learn the numbers and figure out where it came from. That'd be great. I know some of you are just going to fast forward, but go ahead. I'm not going to work through it because you could work through it yourself, but I thought I'd leave it in the lesson so that you could see it. There it is. Push pause and you can see it. It's actually pretty cool. But this is what we need to know, the quadratic formula. It is like the down and dirty. Every single quadratic equation can be solved using this, the easy ones and the hard ones. It doesn't matter. So it is pretty handy. And ACT, SAT tests, it's going to be there. I think you have to have it memorized for it. All right, so let's try one. Find the zeros of that function using the quadratic formula. So just like before, we would set it equal to 0, make sure it's in standard form. Okay, we have A, B, and C. We're going to plug it into the equation. Negative b, which is negative 16, plus or minus the square root of b squared, negative 16 squared, minus 4 times a times c. Okay, I need to pull out my calculator really quick. Sorry, we forgot. Over 2 times a. All right, let's work through all those numbers. 16 squared minus 4 times a times c sorry. Here we have a little mistake. It should be 2 times a. A is 2. So 2 times 2. Okay, I'm going to copy that over to the next slide so that we can work through it. All right, finish through the math. 256 minus 216. Okay, this is where you need to remember some more basic math skills. That 4 in the denominator goes underneath the 16 and the square root of 40. Okay, so 16 divided by 4 is 4. That square root can be simplified to 4 times 10, I think would be yeah, that's right. So that's the same as the square root of 4 times 10, so I'm going to take that 4 out and take the square root of it, make it a 2. And simplify again. So our answer is 4 plus or minus square root of 10 over 2. So in the past few days, you probably would have tackled this equation using completing the square and gotten the same answer. Okay, find the zeros using the quadratic formula. So we get negative b plus or minus the square root of b squared minus 4 times a times c. As you can tell, I'm showing fewer steps each time. This is actually a check it out, but there's one more check it out I'm going to make you do on your own. So keep on simplifying. Negative b plus or minus the square root. Let's see, 4 times 1 times negative 7 is 28. So we get 9 plus 28 over 2. Negative 3. 37 over 2. 37 can't be simplified. So yeah, there is your answer. And I can't divide the 3 by 2. I can't do any simplifying here or there, so I can leave it looking exactly like that. Okay, try this. Push pause, please. There you go. Check it out. All right. Now we're going to have some complex zeros as answers. So we're going to work through it the same way. The complex zeros just mean we're going to have an I in our answer. So let's work through this one together. Negative b plus or minus the square root of b squared minus 4ac, which is 4 times 4 times 2. 32 over 2a. 8. So let's keep on going. 9 minus 32. Negative 23 over 8. And we're pretty close to our answer now. I need to take that negative out because we have to show our answer in the simplest form. And there you go. I can do nothing else to it. You are done. Try this one on your own. Okay, I tried to simplify 95 a little bit more, and yeah, that didn't work. So you are in your simplest form right now. Moving on. The next thing we're going to do is called the discriminant. The discriminant is part of the quadratic formula that you can use to determine the number of real roots of a quadratic equation. So you take your quadratic formula and you just grab this part. This is called your discriminant. And you can plug in the values from the equation in standard form and figure out the number of real roots. You can have 1 real root, 0 real roots, or 2 real roots. Right here, 2 distinct real solutions. These are the ones that give us actual answers. This just gives us one answer. Doesn't happen very often because, as you can tell, I mean, that would just move along the x-axis this way to touch the x-axis in one spot. And here is our complex solutions. Those are the i's. So when your discriminant is greater than 0, you'll have 2. When your discriminant is equal to 0, you'll have 1. And when it's less than 0, you won't have any. And you have to make sure your equation is in standard. All right, so let's work through an example. Like I said, we need our equation in standard form. And we're just going to work through the discriminant. So you remember the discriminant is b squared minus 4ac, just what's underneath the square root. So I get negative 12 squared minus 4 times a times c, 144 minus 4 times a times c is 144. That gives me 0. So I have one real solution. Okay, let's try this one. Standard form. And I get b squared minus 4 times a times c. Again, that's 144 minus 4 times a times c is 160. That's going to be less than 0. You're going to get a negative answer. So we have 2 non-real solutions. That's your answer. We're just looking at the discriminant. And standard form. B squared minus 4 times a times c. Again, that's 144 minus, that one's 120, which is greater than 0. So we have 2 real solutions. Okay, now there's going to be 3 examples for you to do, and then the last slide is what I talked about, that chart that you're going to want to copy down. But try these on your own. All right, we have 1 real solution. Try the next one. Pause. All right, you're a negative discriminant, so there's your answer. Last one. There you go. Now let's look at that chart I was talking about. First of all, this is just for your information to hopefully help you understand the material better. This graph shows the related functions. Notice that the number of real solutions for the equation can be changed by changing the value of the constant c. So these are all the same beginning. X squared minus 6, x squared minus 6, x squared minus 6. And our c has changed. Remember, that's the y-intercept. So we have 2 real solutions, 1 real solution, and no real solutions, 2 complex non-real solutions. So that's how the functions are relating. Oh, the application problems. Let's try them. An athlete on a track team throws a shot put. The height y of the shot put is modeled by that function, that equation. The horizontal distance x in between the athlete and the shot put is modeled by that. So if you think of a graph, person's here, he's throwing it. The time is in t, so that's modeled with that equation, and the distance is modeled with that equation. To the nearest foot, how far does the shot put land from the athlete? Okay, it's a complicated problem, but you guys can do it. Let's work through some of the answers. First, we need to solve the first equation to figure out the time. Negative 16t squared plus 24.6t plus 6.5. So let's go ahead and solve this. Negative b plus or minus the square root b squared minus 4ac over 2 times a. Okay, the math works out. Negative 24 plus or minus, do all of that math, I get 1021.16 over negative 32. That's approximately plus or minus 31.96 over negative 32. That gives me 2 answers. T is 1.77 or T is negative 0.23. Time cannot be negative, so we have that answer. The shot put hits the ground about 1.8 seconds after it's released. Let's go on to the next part of the next part of the problem asks the horizontal distance that the shot put would have traveled in this time. Remember, we're given this equation, 29.3 t. And really, I'm just going to plug in t. So at that time, we know how far the shot put went. 51.86, I believe it's in feet. So we're just going to round. The distance is about 52 feet. Okay, guys, try to work through this one, please. I know you love word problems, but they're really, really important. So I'll read it with you, and then I want you to try to work through it. A pilot of a helicopter plans to release a bucket of water on a forest fire. The height y in feet of the water, t seconds after its release, is modeled by that equation. The horizontal distance, x, in feet between the water and its point of release is modeled by that equation. Okay, this is very similar to the last problem. The pilot's altitude decreases, which changes the functions describing the water's height to that. To the nearest foot, at what horizontal distance from the target should the pilot begin releasing his water? Let's deal with above the squiggly line first, and then we'll go down to the bottom. If you guys can do what's above the squiggly line first, that would be great. So solve for t, plug that in, and solve for x. Time can't be negative, so the time is about 4.9 seconds. Keep going. Okay, time was actually 4.937 seconds. I rounded, but let's keep the whole number there to try to all stay on the same page. So we have x equals 449 feet. The water is going to travel a horizontal distance of 449 feet. So the pilot should start releasing the water when the horizontal distance between the helicopter and the fire is 449 feet. I mean, if you think you've got the helicopter, that looks like something, that's a helicopter. And the fire, the horizontal distance is going to be about 449 feet. So that's why the helicopter needs to release the water when that distance is about 449 feet, so that the water actually, I guess the helicopter should be flying that way. I should fix my picture. Helicopter's flying that way, so the water is going to go in the right spot. No. Let's fix that. Okay, let's move the fire. Let's make this make sense. The helicopter's flying this direction. Oh, my helicopter picture just got worse. That's awesome. I think there's a little plane back. Yeah. So it's flying in this direction. It's going to release the water when it's about 449 feet away, because as it's flying, the water is going to keep on moving and hit the fire. These are those charts I was talking about. It's just the different methods we've learned and what I would choose to graph. What I would choose to solve a quadratic formula, a quadratic function or a quadratic equation. You know, I can graph it, but it just approximates. You know, you don't really want to do that, maybe unless you have a graphing calculator with you, then it would be easy. Factoring, if you can easily factor it, if you recognize the roots and you can quickly put it into, you know, two sets of binomial parentheses, then go ahead and factor. Square roots, if you have the variable side of the equation's a perfect square like that, it'd be easy to do. Completing a square, it says when A is 1 and B is an even number. You don't want fractions. You've noticed how difficult it is to complete the square with fractions. And then the quadratic formula, when numbers are large and complicated, the expression doesn't factor easily, just go for the quadratic formula. No matter which method you use to solve a quadratic equation, you should get the same answer. That's all I got for today.